Hello. In this video, we will understand the implementation and working of Leach, low energy adaptive clustering hierarchy algorithm in wireless sensor networks in NetSim. Leach is a MAC protocol which involves clustering aimed at lowering energy consumption and improving the lifetime of wireless sensor networks. For our example, we use a scenario with 64 nodes divided into 4 clusters. Leach can also be implemented for networks with different number of sensors and clusters. The sensor with maximum energy in each cluster is selected as the cluster head. Cluster heads are updated continuously throughout the simulation. The member sensors in each cluster communicate only with the cluster head via a single hop transmission. The cluster heads forward this data to the sink or base station either directly or via other cluster heads along with the static routes defined in the source code. Note that NetSim's default WSN libraries only have AODV and DSR in layer 3. The DSR source code is taken. A new file called leach.c which contains the code for the above mentioned algorithm is written. This has then been built and the new binary has been placed in the application path. Now to enable Leach, uncomment the line #define_leach at the beginning of the dsr.h file. Next, to enable static ARP, uncomment the #define_static_ARP line in the same dsr.h file. Rebuild the DSR and ZigBee DLLs in the bin path after making the above modifications. Advanced users can modify this code for a different implementation of Leach or for a different L3 routing algorithm. Next, to simulate Leach in NetSim, create a project by clicking on Simulation, New, Wireless Sensor Networks. Specify the side length as 50 meters, select Uniform Placement and enter the number of nodes as 64. Place the sync node and agent as shown. Next, right click on any sensor and select Properties. Max frame retries as 0 and change the transmission power as 100 milliwatt. Right click anywhere on the grid and set properties for the environment. We have chosen channel characteristics as line of sight and path loss exponent as 2. Once the properties have been set, click the packet trace button, enter the file name, select the file type as .csv and specify a location. Then click Simulate button. Select simulation time as 30 seconds. Enter the experiment name and select record animation and click OK. After the simulation is complete, click View Packet Animation on the left side. A window opens showing the network along with playback controls for play, pause, simulation time and a slider to control the animation speed. Now let us study the simulation in detail with the help of the packet animator. As can be seen from the simulation, the cluster heads continuously change. The packet is first transmitted to the cluster head, which then forwards it to the sink. Sometimes the packet is dropped during this transmission on account of propagation losses. Let us look at the flow of two packets to get a clear picture. The first packet, that is packet ID 12, is generated by sensor 13, which transmits it to the cluster head sensor 22. Sensor 22 transmits it to the next cluster head sensor 46, which then forwards it to the sink. The next packet, which originates from sensor 7, is sent to the cluster head sensor 22, where it is dropped due to CCA failure. Similarly, transmissions for all packets can be analyzed. The entire flow of packets can be better understood by running the packet animation at a slower speed and verifying it against the generated packet trace. For more advanced users, the mechanism of changing of the cluster heads can be seen by debugging the code using Visual Studio. Add the variable array ch to watch window, set the breakpoint at the beginning of leach.c and debug through the code. Hope you enjoyed this video on Leach implementation in NetSim.